Hello and welcome to episode 52 of our SAP on Azure Video Podcast. Today is July 29th, and together with Gora and Robert, we're here to talk about anything related to SAP and Microsoft. Hello, everyone.
Yes.
So,
hi.
Today we will look at automated landscape installations. We had previously talked about our offering to install an SAP system via Terraform and Ansible, so all the things that are available on GitHub. And for this, to really dive into this, we have Morgan and Kimmo with us today. But as always, before we hand over to them, let's quickly take a look at some of the news from this week. And I want to start with an announcement or a blog post from Gerald Reinhardt about SuccessFactors integrations. We had talked about this in the past a little, where it's all about, obviously, a lot of customers have SuccessFactors and a lot of customers have Azure Active Directory. So you have these two systems where you track your employees, where you follow your employees throughout the whole hire to retire process. But then you also have Azure Active Directory, where you have all the, let's say, the technical, the IT side of the employee lifecycle. And obviously you want to have these two systems in sync. And SAP and Microsoft have been working a lot together, actually also pulling in colleagues from different partners. And the result of this collaboration is actually a quite extensive white paper or implementation design principle that guides you through all the steps on how to actually connect and combine your Azure Active Directory system with SuccessFactors, so that you can really keep the identities in sync. The next thing that I quickly want to highlight is a blog post about Microsoft 365 and collaborative apps. And as you can guess, it's about the Teams integration. And what I really like is that we're seeing more and more partners working and integrating in Teams. So you can see here Confluence talks about their integration into Teams. ServiceNow has a nice integration here in a chat-based context. Monday, Salesforce, and obviously, as you can guess, Workday. We also have the outlook on the SAP Sales Cloud in Teams. We had talked about this in the past, so hopefully we'll soon see also the SAP Sales Cloud integration in Teams, which then obviously will be very relevant for customers, for SAP customers that already use the SAP Sales Cloud. The next thing is another blog post by Shaukat. He talks about using the business technology platform and consuming services from the Microsoft Graph. So basically, just accessing services on the Microsoft 365 side. And I mean, we had this topic a few times before, but I always think it's nice to repeat some of these topics. And here in this blog post, Shaukat talks about, well, how to do OAuth authentication. Obviously, the Microsoft Graph is protected by OAuth, so he guides you through the steps how to set up the destination service on the BTP, how to then actually configure OAuth with the credentials that you got from the Microsoft Graph, and then how you can do this and actually develop an application around this and really consume services from the Graph. Then another blog post by Bartosz. So you remember we talked about that Bartosz is on a mission. So every week he's going to publish some blog posts about Azure Synapse, focusing on OData. And so last week already he released part 2. Just today he actually released part 3 and talked about metadata store. How you can connect obviously to the OData services and read the metadata. What I'm actually very excited about is if you read through this whole blog post, and it's certainly worth a read. But then he also really talks about, well, so I'm looking forward to for the next blog post of him, because he's already saying, well, here in this scenario he is using, somewhere he wrote this, that he's using just a few hundreds of line items, but obviously in a productive environment, you have much more. Yeah, you have much larger data volumes, and typically OData is not generally the best protocol to handle large data, but here with millions of records. But apparently, Bartosz will talk about this in more detail in his next blog post, and show how this can be done with OData and Azure Synapse Pipelines. Good. And then a last blog post, I mean, following up on the session that you had last week with Martin Pankratz. So it's really nice to see all the work that Martin is doing in this area with Private Link. So the Private Link service, as you hopefully know, is currently in beta, so you can test it out. Martin has a lot of content out there. Last episode, we talked about this. And this time, he's really talking about this really getting this in a productive environment. So the idea is obviously you don't only have one system, you have multiple systems, you have multiple sub-accounts on the business technology platform, probably a sandbox or a dev, QA, and production sub-account. And there's obviously then the question, well, how does Private Link, how does the SAP Private Link service work with these different spaces on the business technology platform? And he talks about different scenarios, how the setup could look like, how you would connect different the Private Link service to the different instances, and yeah, so it's a really nice walk through different scenarios. Obviously, also yeah, here in the end with Traffic Manager and how you can really build up, I would say, high available or disaster recovery scenarios. So I really like the work that Martin is doing here and really showing how you can use the Private Link service really also in a productive environment. So it's definitely also very much worth a look, this blog post here. Good. With this, I think that was all for this week from my side. With this, again, we have Morgan and Kimmo on the podcast today. So maybe, Morgan, Kimmo, maybe you can quickly introduce yourself, and then I'm looking forward to the presentation and the content that you have prepared.
Sure, thank you, Holger. I'm Morgan Deegan. I am the program manager for SAP Deployment Automation Framework and driving this product forward. I've been with Microsoft now for a little bit over a year and a half. And previous to that, I was an SAP basis engineer for about 25 years.
Cool.
So you look also like a SAP Basis Viking veteran.
The first version of SAP I was exposed to was 22D+.
Really?
Yeah.
Okay.
My goodness.
Right. So yeah, my name is Kimmo Forss. I'm the kind of Morgan's partner in crime here. So I'm the dev lead for the automation work at the moment. So helping in building the Terraform Ansible code and doing some of the testing and validation. 20 years this year with Microsoft. I'm not an SAP expert, so the reason why I'm involved is I know Azure and I know automation. So that's the reason why I'm part of this project.
And Kimmo, last but not least, you're my colleague, you know.
Yes. Yes. We're in the same team with Laura.
We are in the same team there.
Cool.
Great.
So when we start, so I have a slide that I would, with a few slides to kind of provide the context. And then we can start with that and then kind of start looking at the actual repo and solution after that. Is that okay with you guys?
Yeah, perfect.
Yeah, please.
So I assume that you can see
Yep, we have it.
the PowerPoint. So Morgan, this is actually where I would defer to you. So can you share a bit about the vision, why we started building this and what our ultimate goal with this is?
Sure, I'd love to. So, it all started for me when I was at one of my customer sites previous to Microsoft. The challenge was supporting so many different SAP systems in so many different dimensions. You have an SAP product, you have the production landscape, you have a project landscape, and you never just have one product. You've got 10 or 15 different products running, and that scales hugely. And we get into problems with divergence, with the manual effort of configuring SAP systems. A human creates these things and there's differences between them, and you have to spend so much human capital to just troubleshoot problems when it's just one really small change. So by approaching and looking at automation and defining your infrastructure as code, which Terraform is really good at, it allows us to have a consistent deployment that we can govern continuously. And Terraform is good because it is very English readable. You can embed comments into the structure. It breaks things down in a way that is really easy to write and to read and see what's going on. For Ansible, Ansible's configuration as code, or handles the configuration as code section. So again, it becomes that divergence and repeatability thing. System administrators have historically gone onto the OS and performed configuration activities, and maybe they forget to do something, or maybe the locale is set wrong, or they forget to install a package. Defining your configuration as code provides a consistent way to repeatedly hit the same target time and time again. And Ansible, again, is really good at doing that. It is agentless, so you don't have to install an agent for it to run. And it goes in and it becomes your hands on the keyboard to perform all those system administration tasks to configure the OS, set up your disks, prepare for SAP, and continue on into the SAP install portion of it.
So to say it's now much better to work with Ansible and Terraform on the end than like old-fashioned preparing images, then maintenance of those prepared images, and patching images. So it's much better actually to install everything from scratch because it's much safer, much more easier to do, and you don't have this extra maintenance job to do later if you're going in the direction of standard, prepared images with different use cases.
Correct. You're getting a consistent and reliable output each time.
Yep.
Yeah. I mean, somebody was from a partner also telling me that in those Azure projects, when they do a manually meaning you use typically the portal, then you manually configure inside of the OS the stuff, like it takes per one SID, maybe 15 days. And they might have 100 such systems, right? Which means it's extremely time consuming and it's like very error prone. So meaning with those automation, I mean, you can first speed up the whole process and standardize what you are doing. So basically avoid the common mistakes. And there are many of those gotchas configuration part where somebody could wrongly, accidentally set something wrong or not set, right?
Yeah, exactly. And also one of the benefit of defining your infrastructure or your configuration as code, you can also add intelligence and experience into those configurations. So we can actually make sure that the templates that we're building follows the best practices. We can make sure that the configuration we do actually aligns to the recommendations from both our engineering groups and from SAP. So that way we're not depending on the knowledge of the operator to do the right thing, because the automation will have it baked into it.
Yeah, and Goran, you bring up a very good point. You mentioned that, doing things the traditional way, you can take like 15 days just to configure these servers and the OSs. From start to finish, right now, we can deploy infrastructure and have a S4 system up and running that you can log into that has, multiple application servers, a database server, and an SCS server. Cool. That whole thing can be stood up in 2 hours.
Yeah, and I think what is very important, because we are discussing as a code part, in configuration part or infrastructure as a code part, and this as a code part mean that we can use standard DevOps procedures, what we already used to have on a standard development environment.
Yes.
Yeah, that is correct. That's something that Kimmo will be addressing soon. Okay. Is we have the individual tools, but the larger vision is to consume these tools in an orchestrated fashion. And Kimmo's going to be working with ADO to provide some sort of orchestration offering.
Great.
Yeah, exactly. So Yeah, and the way that we've looked at, so like even though like SAP is there's so many permutations, there's a lot of variances, but if you look at it from far up enough, you actually see a lot of commonalities between the different systems. So for an SAP system, ultimately it's VMs and storage. So what we've done in the Terraform templating, actually creating these common building blocks that we use then to assemble the solution. And this slide actually talks about some of them. So we have a deployment environment that we provision, and think of that as the control plane from which then the subsequent deployments would happen. We have the storage part that we deploy. So this storage is actually not for the SAP systems themselves, but this storage is for maintaining stateful information from Terraform. It's for maintaining the SAP binaries that we download from SAP so that we can perform the actual installations. Then we've abstracted the concept of the workload. So if a customer has, let's say, a dev, QA, and prod workloads, we've abstracted them into one deployment artifact. And then the final one would be the actual system itself. So those kind of become the building blocks that we use in the deployment orchestration that Morgan mentioned. And then from an Ansible point of view, we've done a similar approach. We've actually looked at the configuration tasks and split them into different Ansible playbooks, essentially. So like we have a playbook that we run to do the base OS configuration. We have a playbook that does the SAP specific, etc. We have a playbook that manages the installation media. We have playbooks that install the software on the different components of the system. So it's very kind of granular, and like Morgan said, our ultimate goal is to build an orchestration layer that you can just essentially provide the input in. So this is what my infrastructure should look like this is how many application servers I need, this is the type of database servers I want, and this is the SAP software, and then the orchestration will actually kick in and do the deployment. So when we look at the framework, so this picture actually talks about the infrastructure deployment, because so this is from the outside creating the VM. So if you kind of follow the flow, so we are working in GitHub, so everything is being worked open source. So there's nothing like all the code artifacts are always visible. So they might be in different browsers, but a customer can at any time just look at what we're working on. But then the flow from a deployment point of view would be that, so let's say that a customer wants to start using the framework. So they would clone the repo into an execution environment. This could typically be the Cloud Shell for the first deployment. And from the Cloud Shell, they would initiate the deployment of the deployment infrastructure. So for those of you who are familiar with enterprise scale or cloud adoption framework, so the first deployment would actually be something that we would typically deploy into the control plane or the hub in a hub and spoke scenario. So that would include actually deploying the deployment infrastructure, which in our case is a control plane VM that has Terraform and Ansible so that it can then perform the subsequent deployment activities. We also, as I mentioned, from a storage point of view, we provide a container where we can actually persist the SAP software. And the reason why we're doing this is, well, you can probably explain that better, Morgan. Like, why do we want to store the software in a customer's environment?
So customers will typically have requirements, regulatory audit requirements, especially if they're public companies, and they'll want to keep copies of their software. And sometimes they're required to for quite a few years. So by storing copies of the binaries locally in a storage account, it gives you a repository to repeat installations consistently over time to the same versions throughout the life cycle of the landscape for that initial deployment. And it gives you that consistent starting point. It's repeatability and its locality. SAP tends to update certain elements of the software like SWPM or SAP CAR or some others quite regularly. But to achieve consistency, you might want to still use that original version for the install.
That's actually pretty important, I think, and pretty interesting. That you're not only talking about persisting the actual, I don't know, NetWeaver installation files or the database files or something like that, but you're also talking about persisting the SWPM, so the actual installer that does the installation, so that you can really make sure that whether you install it today, that in a year from now, you can do the very same installation and know that it will work because it worked before. Because otherwise you might run into an issue that maybe SWPM has been updated because of some very good reasons, but now all of a sudden you would have a situation, a combination of installation files and installer that might not be compatible anymore. So by this, you really have everything isolated and you can do the installation in a very repeatable manner.
Yeah, that's very true. One example of that is around, version 7.3 when it came out, they changed the way the CI and the SCS were. That's when the actual SCS or ASCS came into existence, was at 7.3. And before that, the message server and enqueue server were embedded into the primary app server, the CI, as it was called. So there have been architectural changes over time. And if you use newer installation tools to install an older product, your architecture will change. So the whole goal is to be able to repeatedly install the same product at the same target over time, because you might install your dev system in January and your production system in December. And because of the transport management system, you'll want them all installed the same, and you'll be rolling those transports, those support packs, those upgrades forward through your landscape to get consistent testing all the way through.
Yeah.
So if anybody's been around SAP long enough, we all remember that they used to ship the SAP product on CDs. So this is basically going back to that same thing. You're freezing your installation media.
Cool.
Okay, cool.
Yeah, and that is kind of what we would store in the management layer or in the hub. So then following, like the next step, once we have the deployment environment in place, the next kind of logical construct is the workload zone. So this, as I mentioned, this could be the non-productive systems or productive systems. This could be partitions like dev, QA, and prod. In essence, what we abstract here is typically the virtual net, because most customers tend to put different tiers in different VNets. So this would abstract the VNet, and this would also be the place where we store credentials, etc. So what we've done from a security point of view is that we're heavily leveraging Key Vault. So we're using Key Vault to persist credentials for the systems, for service principals, for deployments, also for the SSH keys for VMs, etc. They're all stored in Key Vaults that we automate. And then the final kind of step, once you then have the workload, then you can start deploying the systems. So, and then it becomes repeatable. So once you have, let's say, your dev environment, then you can just repeat and deploy another system, another system, another system. So that becomes the next kind of repeatable framework.
Yeah.
And as you can see in the picture, so currently we have ways you can run these tools manually, like using Terraform commands. We have accelerator scripts that you can use to achieve the same goal. What we are working on, and what Morgan mentioned, is actually moving into Azure DevOps so that customers can have pipelines. So essentially, when I need to deploy my SID, let's say X04, I would just store the configuration in my repository and kick off a pipeline, and that would deploy the system. So it becomes a very kind of a predictable process. And kind of from a flow point of view, kind of this is how we're kind of looking at this. So we have the concept of an Azure region, and then we have the workloads, and then we have the system. So it brings predictability, because it doesn't matter if the customer is deploying into one Azure region or multiple Azure regions. It's a consistent pattern. So they know that they're deployed the same way. They have the same underlying structure across all of the areas. So it makes it, the operational excellence becomes much better, because you have consistency across the board. You don't have to worry about like, how was this system deployed versus how was another system deployed. So let's actually start looking at some of the actual deployments, because I think that's probably more interesting. So let me jump into. So what I've done here essentially, so this is our repo. So we have all the code is here. So currently we're working in the beta branch. All of the Ansible stuff that we mentioned exists here. All the playbooks, etc., can be found in the repo. You go and look at Ansible, all the tasks, etc. here. So ultimately, the first thing that you do once we've deployed the system, so to kind of show you a bit about the consistency. So I've deployed 3 systems. So I have a SID here called X00. I have another SID called X01. I have a third one, which is an HA setup that has then more servers zonally deployed, etc. But you start seeing that there's commonality and consistency. So one of the things that we actually spend a lot of time planning is how do we define kind of resource naming, etc. So to have a consistent fashion and have a predictable model for defining resource naming, etc. So if you start looking at the deployed system, so it's deployed using the Azure best practices. So you can see here we have proximity placement groups. We deploy all of the load balancers, the VMs with their disks, etc. And they're all deployed in a consistent fashion. So if I, for instance, want to go on, let's look at the HANA database. So the HANA database, for HANA, we're using the recommended guidance from that the disk configuration is based on the virtual machines queue. So you don't have to worry when you do the deployment. So how do I configure the disks? All that logic is baked into the templates themselves. And then they're fully dynamic in the sense that if I then need to change this, I can, by changing the larger VM size, we can actually grow the disks, etc. And then so it's very, very configurable. And the way that the configuration for these systems is done is, let me actually switch to VS Code. So when you think about Terraform templates or any templates, usually you combine 2 things. So you combine the templates and then you combine the parameter. So this file actually here would be the configuration file that we have that defines one of the systems that I just deployed. My mouse is acting up, so let me just. So as you can see here in the screen, so some of the key things that we ask the customers to define when they do the deployment are just the environment name. So this is the dev system. This is located in West Europe. It's part of a logical VNet called SAP01. And then, sorry about my mouse is acting up. 1 second.
That must be a pattern. I think we had a previous show where also everything was working well, but the mouse was not working.
Yeah,
we need to have a mouse in availability. Huh?
Yeah,
exactly. That was I want to tell it.
Or kill the cat.
yes.
So in essence, sorry about that. I don't know why, but as you can see, like we have really rich configurability, so we can define the images that we use. So in this case, we did a deployment using the SUSE version 12 Service Pack 5. We have the ability to define networking. If you use DHCP, etc. So for a customer, when they start thinking about like how do they use the automation, so this file, kind of think of this file as the blueprint for your infrastructure. Mm-hmm. So this would have the pertinent data, like what is the SID, how many application servers do I need? Mm-hmm. So I need 3 application servers. I just want 1 SES, and SES doesn't need to be highly available, the instance numbers, etc. So this becomes an easy, once you've defined this, then we can just start deploying them, and then we always get the consistent fashion. So, and then the beauty of DevOps approach like this is that, so if for some reason we need to say that, hey, actually, I need to grow into a scenario. So for some reason, let's say that this system actually becomes more critical, and then I actually want to convert this to become highly available. I just need to change the parameter and redeploy the infrastructure. And then what that deployment would do, it would add the additional central service virtual machine, and then I would run through the Ansible and it would configure it as well. So it actually becomes a really, really easily manageable process for the customer, from the customer's point of view.
But Kimmo, it's not that I would start, for example, with a non-high available setup and then I would just run the script again in a high available manner. This would be another setup then.
You could grow, so you could scale it from a non-HA setup to an HA setup. And we actually talked about this with Morgan just before this call. So like think of a scenario where you're running your primary systems highly available, let's say in one Azure region. Mm-hmm. And then you have your disaster recovery in another region.
Okay.
So the disaster recovery would probably not be highly available because customers don't want to pay for resources that they're not using. But what if there's a really, really serious outage then in your primary region and it will never come back? Mm-hmm. Then you have your DR environment, but then you would like to scale it up to become your production environment. So that could be a scenario where you would go from a non-HA to an HA scenario.
I think that's also extremely powerful. So I would just change the parameter here. Yes. I would run it again, and then my environment.
Yes. Well, I'm lying a bit. So you have to change two flags. So you have to change the SCS, and then you also have to change the database.
Yeah.
But yes. So then what we have and then once the orchestration would then. It would run through, it would configure those servers, and then we also have a playbook that you can then run to configure HSR, for instance, between those two things. So it becomes truly a way that we can scale up and scale down if need be.
Yeah, truly handling that scenario is a lifecycle type activity. You know, any lifecycle activity requires an orchestration because there's many steps to some of these activities. But yeah, like Kimmo said, any event that's going to take down a region is not going to be a couple of hour event. It's going to be a long-term event. It's going to require, you know, it's going to be critical and catastrophic to take down a region. So if you're going to your DR region, you're going to be there for a period of time. And if you were HA in your primary region, chances are you'd want to be HA for that period of time that you're in your new primary region.
But it's very interesting because you mentioned the life cycle. You can actually configure one DR pipeline in DevOps and just switch to that pipeline if you want just and everything pre-configured there, so you don't need to invest extra time at all. So it's everything ready for disaster. I mean, it's amazing. Very good.
This is the vision.
Yeah.
And as we talked earlier, we're working towards that. Mm-hmm. So we don't have that orchestration at this time. We have the tools. So we're going to be developing that orchestration. That is one of the orchestrations that will be coming.
Yeah.
But that's the whole vision and concept behind it, because you want to be able to transition to your DR environment. You want to be able to transition from standalone to HA and do that seamlessly once it's up in a nonstop, no impact manner.
Yeah, I just changed the flags to true, and I kicked off a Terraform deployment. So what we should see in a short while, we should see that then the additional SCS servers, the additional SCS server and the additional database server would pop up in the portal, and then we could actually continue with the next step. So this is again where Terraform goes and validates what was already deployed, and it now says that, hey, your configuration now is telling me that, hey, I need to have two of these servers, two SCS servers and two database servers rather than just one, and then it would just kick off and actually do the deployment automatically.
You already, I think, deployed availability set for DB. It's already there.
Yeah. Well, the key behind this is you always build your infrastructure HA ready. meaning the delta between a standalone environment and an HA environment is simply the number of servers. Everything else remains the same. You still get a load balancer either way. That way the new server gets added behind that load balancer.
But that's really great. So even if I start small, you would already prepare the environment or install the environment in a way that I can easily scale it up afterwards. And I mean, since we are talking about, I don't know, a load balancer, there's also no huge additional costs involved, but I'm already ready to scale up.
Correct. Yes.
Yeah, that's correct.
If you look at the repos,
and it doesn't require an outage, because when you do that, if you're not prepared for that, you're going to have to take an outage to reconfigure IP addresses or whatnot. So this way you don't have to do that. It gives you an ability to have a near zero downtime methodology.
Exactly. That's why we're putting load balancers in front of the central services and database, even for a single tier deployment, just so that we get the additional layer of abstraction, which allows us then to do additional work behind the scenes.
Interesting. And basically then from a SAP landscape perspective, what I see, you can have a central system, you have a distributed without HA, and you can have an HA system as well. And HA could be either availability set or it could be zone.
Yes, so that's an example. So if you look at the configuration file, so we have the ability to provide the zonal information. So when we do a deployment, we can say that, for instance, you can see here on line 116, when I do the zonal, if I say a zonal deployment, then I can say into which or across which zones do I deploy. So that's already all kind of built into the solution. One of the things that you have to be careful about is that if you're, like we all know, you can't go from a non-zonal to a zonal without having an impact. So if you would tell Terraform that, hey, my system that was deployed non-zonally, I now need it to be zonal, then we have the same challenges that we would have without any automation, because you can't move from non-zonal to zonal.
Yeah, of course. Yeah.
We also have to remember that not all Azure regions would support zonal deployments for HANA due to latency requirements. Other databases would not be as impacted by that, but HANA has very tight, low latency requirements.
Okay.
Yeah, so that was how you would configure the infrastructure, and then for Ansible, so the orchestration is still kind of we're still working on it. So the last thing, so this is my second environment that I was running. So the last step I actually did here was that I ran through the database load on a Red Hat based system. So then the next step for orchestration would be I've done the database load, then the pass install, and then again the Ansible playbooks would then go and fetch the right details, connect to the first application server, and run SAP inst in an unattended fashion, and then in after a few minutes we would have then the pass installation done.
But question is, how would you, or how the customer will get the install medias?
That's a perfect question. So we originally had thought that would be something that we would document for them, how to acquire the media and acquire the software. What we've done to accelerate this process is that we have a set of sample bills of materials for a number of SAP systems. At the moment, for instance, the one that I've been deploying is S4 1909. So essentially, we will provide a file that is the blueprint for this application. So this file actually then will contain all of the files that are needed to do. So this is the inventory of the CD essentially. And then these links are then the links to how the customer can download them. And we have an Ansible playbook that is called the software downloader. and then the customer would run this playbook, providing us or they don't have to provide us, but for that playbook they would need to provide their S username and password, and then that playbook would download the software from here and put that into the storage account that Morgan was talking about.
This is an important step because by the user providing their S user and their password, they are the agent or agency that is doing the acquisition of the software, is going through their licensing check, it is going through their export control check that SAP does. So if they're not authorized for that software, it won't be available for download.
Cool. So basically, you're not just listing what is needed with what kind of media exactly, but also you're giving them ability through the runbook to automatically download from the SAP by specifying also their own S user and password, right?
Yes, and this is one of the places where we're using, again, Key Vault. So as part of the workload Key Vault, we would have two secrets, the S username and the password, and that would be used then to acquire the software and then download it and then upload it to the storage account. So that process will work for the sample bills and materials that we create, but it will work as well with customer provided bills and materials. So in essence, so let me just show you where these would end up eventually. So they end up as a flat list in a storage account. And the reason why we're doing that is that way we can avoid deduplication. So because many permutations are using some of the same files when you're doing the deployment. So we just put everything into one container, and then we have playbooks that actually then go and all the media. So this is your jukebox with CDs essentially. So all of the files are here, and that gives, and since they're in your control, you can keep them around as long as you want.
Correct. Also, this BOM process there's a lot of different permutations of what you can do with it. It actually creates a framework for installing SAP. So a customer, not only are there the BOMs that we're providing, which are basically just starter BOMs, it's a way to quickly be able to deploy the S4 product, but the customer can do the traditional method and create their own BOM as well by using the same process we do, going into SAP's portal and going through the maintenance planner, defining, a deployment and downloading the software. That's exactly how we generate one of these BOMs. So they can fine tune what product and what support pack levels and what add-on components are getting installed all at once. Also, the BOM, say you want to do a system copy or a system refresh type activity, you can use the SAP tools to do the database export, which is pretty much for HANA, it's just a backup, and you replace that as the export media inside the BOM, and now when you install, you'll be installing from a customer copy of a database or a gold copy of a pre-configured system that the customer created. So there's flexibility and options, and these are other lifecycle type activities that it enables.
And by the way, the pass install just finished, so it took 300 seconds, and then the orchestration, I could move to the next step, which would then install the rest of the application server. So again, it becomes predictable. It's done the same way every time. So one of the questions that I got from customers and partners, so like the worry is that since this is automation, how can I know what gets deployed? And that's one of the reasons why Terraform is actually really nice, because the customers can easily just, if they want to, they can easily just look through all the templates that we have here. But then the other question that I tend to get is, so what about like the operating system? Like what type of configurations do you do on the OS level? So the way that our playbooks are written is that we actually have a set of files that define the system and all of the services, etc. So for instance, this one that I'm showing now, so the customer can say that in my Red Hat 8, VM, I want these services to be started, these services to be disabled, etc. And so, for instance, we're using the central services instance as an NFS server until we ship the Azure NetApp Files support or Azure Files for NFS support. So we're using the SCS as an NFS server, so you can control this in your configuration. So on the SCS server, the NFS server needs to be in a started state. Same thing goes for like if you want to know like which packages we will install as part of your environment. So again, they're all documented as part of the playbooks, which makes it easy for InfoSec or someone actually to, if they want to say, okay, so what does the Microsoft automation do? They can just look through this. Okay, so these packages get installed. We have another package that we may want to have as part of them. They could just append it to this list. Yeah. So it becomes very, very transparent, all that we do.
InfoSec will typically, want to do a code review, and here the code is all there so they can see exactly what's going on. And when they approve, an automation, they've reviewed the code. Now, in the future, all they need to do is review deltas, any changes, the code can remain static and they can update it at their own pace. And then once you have approved code, then you can put it behind some sort of workflow orchestration too. So instead of having to have different people in different departments necessarily do the execution, you have different people in different departments approve the execution of the automation.
Yep.
Yeah, and now the application server install finished, and it was 158 seconds. So
how many app servers did it install?
Just one. So I had two app servers in this.
Okay.
Yes.
So you could have multiple app servers and it would install them serially, one right after the other. It doesn't do app servers in parallel. So it took 100 and whatever many seconds per app server to do the install.
Mm-hmm.
And you would have also different, I believe you use this bill of material to define, okay, I'm installing this kind of SAP product as for HANA, which is with the HANA database, right? So what at the moment, there are a huge number of SAP products, right? With a lot of database combinations. So what do you have at the moment? What kind of products, what kind of databases, and generally speaking, how can we talk also a little bit about the roadmap? What's kind of also planned as well?
Right now, we only have S4 as the initial offering. We're working on with HANA. We're working on providing NetWeaver and Solution Manager. Those will be the next available bill of materials that will be available. Solution Manager will be both ABAP Stack and Java Stack.
Right.
It's the exact same framework to install any of the SAP products. So the only thing that really changes is the BOM. Mm-hmm. So we may be providing these starter BOMs, but the customer will always have the ability to create their own BOM.
Mm-hmm.
So provided they create their own BOM, they can install CRM. Of course, right. Some of the add-on components wouldn't be installed. That would still be a manual process, like that live cache server that goes with CRM. We also have the ability to turn on and off the app tier deployment, so you can wind up with a standalone database server deployment. An example of that would be for HANA Sidecar or for a DR instance in another region. And we have the ability to turn on and off the database tier of the install, so you'd only have an application server install. And you might want to do that if you have an HLI as your database server and you only need the app tier in VMs.
Right. And then as for databases, so currently we have HANA. The next thing that we will release is support for configuring pacemaker from Ansible. So that's the next immediate thing on the roadmap. So having then once we have that, then we have full HA support for HANA-based deployments. Then we will start working on AnyDB. So probably like doing DB2 and Oracle and then Sybase, and then also providing that.
SQL Server, come on.
At then one point also Windows and SQL. So it's we like that. There's a lot of things that we want to do because, and also in parallel to those is to provide like Azure NetApp file support for shared files initially, and then also once Azure Files for NFS becomes an option to make sure that our automation framework supports that. Plus then the work that we talked about, actually moving these deployment activities into pipelines in Azure DevOps.
But I'm thinking, I mean, having ability to install full product, it's great. And I mean, it takes a lot of time to, I mean, also roll it out, test it, and so on. But honestly, I mean, even if the customer will get just quote unquote infrastructure, it's a lot because I mean, I'm interpreting this. They could use it without install SAP stuff, but still get the infrastructure, which is a lot, right? I mean, they could use for the different databases, just use the infrastructure. Okay, do it by themselves, the installation part of the SAP, but still use it, the existing automation to build the infrastructure surround story, which is a lot of work, manual work if they would imagine.
And because
we have some customers who have chosen some other configuration management technology. So like someone who's using DSC if they have Windows estate, or someone who may be using Chef or Puppet. So our stuff works great together, but we're not forcing you to move to the next step. So you can just do the infrastructure deployment. However, our ultimate goal is to make it so seamless that you wouldn't even think about not doing it.
Okay. And also because we have a modular type of approach to it, you could deploy the infrastructure and then do the OS configuration, which basically we wanted to achieve a level of hardening for the server. You don't have the SAP servers that it runs on. It could be for anything, really. But it brings you up to a consistent configuration that you can then move on to the next step. So you could run through the OS configuration, through the SAP configuration, and then perform all the SAP install portion manually. Right. And that way you have a consistent starting point.
Exactly. And still it's a lot in my opinion. I mean, it's a big thing, all those infrastructure. I mean, so many VM disks, I mean, could be hundreds, thousands, right?
Well, like you said, 15 days can be spent, making sure all the systems, and we can reduce that to 2 hours.
Cool.
So maybe one final question then. Now I'm all excited, and I can see Kimmo is continuing with the installation, with everything. Now I also want to do this. So you quickly talked about the GitHub repo, but maybe you can quickly go back. I think it's SAP-HANA.
Yes.
What's the branch that I should use now? So if I let's say if we have a listener or a viewer who is now interested and wants to give it a try, what would be the first step?
Oh. You would go to the repo, you would go to the beta branch.
To the beta branch. Mm-hmm.
Yes, and then we have, actually, let me take it this way. So we are in the process of actually this documentation will be moved to docs.azure. So like these links will change and the content will change once we get the stuff moved there. But in essence, we have these workshops that you can actually walk you through. You can walk through a manual where you would actually do it using the Terraform command lines. We have an accelerated one where we have acceleration scripts, and then we have the Ansible part. So this workshops folder actually talks you through the whole thing. So there's and here's also a a workshop for doing the software download. So, and for customers, that would be something that they have to do because otherwise there wouldn't be anything to install. So in the documentation, SAP Automation and Azure Software documentation workshops, you can actually you can run through these and you will get a fully deployed S/4HANA deployment done. So if you would go, for instance, to the workshop, there are then all of the steps that you need to do and to deploy the deployment environment, deploy the library for the binaries, etc., and then deploy the workload VNet, and then deploy the actual system. So by kind of going through this, you can actually achieve the full installation.
That's true. And the SAP software install is in private preview right now. So we do ask that people sign up for that. Otherwise, you might be missing some information that you need to achieve a deployment of the software.
We will share the link with you so you can put it in
that's good.
to the YouTube notes.
Yeah.
Cool.
Perfect. Well, I think that was really great. And we saw that you're almost done with the installation. I saw you added more and more components. So yes. That's really great. It looks like that's really working very seamlessly. Great. I think with this we have a very good overview. Thanks for all your answers, the great presentation. I think we will definitely have you on the show again once there's additional content, once maybe you're out of for the preview, when it's really then available GA. Maybe one last thing. So this is on GitHub. So this is open source. This is
everything is fully open. Yeah, like everything is there.
Yes, and for the configuration as code, SUS is a development partner in that effort.
Oh, perfect.
Cool.
Okay.
Yes.
Yes.
Nice.
So they're a very large contributor.
Yes.
Cool.
Yeah, we have an engineer assigned from SUS to us to help with this. So.
Yeah.
Fantastic.
And I know we have already some pilot customer who runs successfully with Kimmo.
Yeah, exactly. We do have customers who have deployed their production workloads using the infrastructure piece. Not yet too many who've deployed like the application because that's still in private preview. So.
Cool.
Okay.
Great.
Cool. Good. Then I think that's it for today. Again, Kimmo, Morgan, thank you very much for joining, and we'll definitely see each other again on the show.
Yes, thank you for having us.
Thank you, guys.
Guys.
Bye-bye.
Bye-bye.
Bye.